All right, class, welcome back. We are going to talk about solving more quadratic equations, but we're going to give you another tool in your tool set. This one is called completing the square. This is going to go back to what we've been factoring all semester or multiplying out, perfect square trinomial. So if your trinomial is in this format where this first term is a perfect square and the last term is a perfect square and the middle term is the root of this one times the root of this one doubled, then it will factor to a plus b squared. So what's an example of this? Well, if we took x plus 3, say, and we square that, means we have two of these, and FOIL this, we get x squared plus a 3x plus another 3x plus 9. So you can see this pattern. We've got a squared here. This is a squared, x squared. We've got b squared, 3 squared is right here, and we have 2 of a times b. So this is a perfect square trinomial. If this hasn't clicked before, hopefully it will now, that this perfect square trinomial and this binomial squared are the exact same expression. They have the same value, they're the same thing, they're just written in a different form. One is written as a trinomial multiplied out, the other one is written as a binomial in factored form. These are equal to one another. Okay, so if the perfect square trinomial has a positive here, then there's going to be a positive right here. And if it has a negative right here, then it's going to have a negative. The last term is always positive because a negative times a negative is a positive, and so is a positive times a positive. So if we wanted to make a perfect square trinomial, what is this number right here? How do we come up with this? Well, if you can see here that this middle term is 2 of these, then what we would do is we would take the coefficient of this middle term, 6, divide it by 2, which would give me 3, and square that. That is where this 9 comes from. Okay, so what did I just do here? This is the process of completing the square. We're going to take the middle term, which is coefficient, or we'll say that b is the coefficient of the x term. And when we say the x term, we mean if it's w to the first power, p to the first power, y to the first power, whatever the case is. So to complete the square, we're going to take b, divide it in half, and square it. So if I gave you kind of an open-ended polynomial here and said, what would you put here to complete the square? We would take the coefficient of the x term, which is 4 in this case, so that's the v value, divide it by 2. Well, 4 divided by 2 is just 2, and 2 squared is the value of 4. Again, that's a positive 4 here. And so the value that I'm looking for here to make this a perfect square trinomial is a plus 4. This is now a 3-term perfect square trinomial, so we can create perfect square trinomials. Let's do this again. So if I had y squared minus 18y, and I wanted this to be a perfect square trinomial, I would take the value of b, which is negative 18, divide it by 2, and square it. Well, negative 18 divided by 2 is a negative 9. Negative 9 squared is a positive 81. Again, this value then is what I'm going to put right here to make this a perfect square trinomial. Okay, let's practice this 2 more times. Maybe give yourself a second, pause the video, see if you can figure out how to do these for just a moment. So highly recommend completing these on your own. So let's say that we had w squared plus 6 here, 6w, or a p squared minus 14p. Okay, so go ahead and pause the video and tell me what you would have to add here to make this a perfect square trinomial. All right, so we're going to take the value of b, which in this case is 6, divide it by 2, and square it. So the value here that we should be adding is a plus 9. Here we're going to take a negative 14 and divide it by 2. That is a negative 7. And we're going to square that. Negative 7 squared is a plus 49. Okay, so hopefully that's pretty good practice. So this is clicking, but they won't always be so beautiful. So let's talk about a couple other things that you might see. What if I don't have a whole or an even number that divides easily by 2? What does that look like? Well, I'm still just going to take 9. That's the coefficient of the x term, or the variable to the first power. Divide it by 2 and square it. Well, this literally says 9 halves times 9 halves. When we multiply fractions, we multiply straight across the top and straight across the bottom. So the value here, 9 times 9 is 81, and 2 times 2 is 4. So we'd be adding 81 fourths. I know it sucks to see a fraction here, but this is still a perfect square trinomial, by definition of a perfect square trinomial. So go ahead and maybe pause the video and try to do this one on your own. All right, so you should have taken negative 5, because that is the coefficient of the variable term to the first power. Divide it by 2 and square it. Again, this is going to be a negative 5 over 2 and a negative 5 over 2. Well, when we multiply fractions, we multiply them straight across the top and straight across the bottom. So what we would get here is a positive 25 over 4. Okay, so that's just to kind of see some ugly numbers, some not so perfect situations, even though they're called perfect square trinomials. All right, we could also have coefficients of the squared terms. So perfect square trinomials, we only want to complete the square after we have factored out the GCF. So again, this is this like step right here, but we're just working with expressions right now, not with the equations yet, just to solidify this concept. So what I would want to do is factor out this 4 and say this is m squared plus 10m. Okay, what I'm looking for is the missing factor right here. Well, the coefficient of the x to the 1, or the variable to the first term, is 10. So it's this one right here, not this one, after I factored out the 4. So I'm going to take 10, divide it by 2, and square it. Well, that is 5 squared. So what I would add right here is 25. But I want to note that the value that I added is not just 25, because this 4 will belong to everything inside of here. Okay, so if I wanted to say, well, what would this original 3 term have been? I can see where I get this 4m squared and this 40m, but here I have to multiply the 4 times 25, which would actually be 100. So when I inserted this 25 right here, the sum total value of what I inserted was actually 100, because 4 times 25 is 100. This is really important to note when we start getting to the equations, because whatever we do to one side, we have to do to the other, and we want to add the total value. Okay, and in this case, this is not just 25, it's 100. Again, we'll talk about this more. I want to give you one of these and tell me what you would put here to complete the square, and then what the total value is that you would be adding. So let's do negative 6p squared plus 66p. Go ahead and pause the video and tell me what the sum, what you would be putting as the b squared term and what its value is in sum total. Okay, so we're going to factor out this -6. We would have then p squared minus 11p. Okay, so I'm going to take -11, divide it by 2, and square it. Again, this is like a fraction that doesn't come out to a whole number, so we're just going to say straight across the top and straight across the bottom. So what I would be adding in this first parenthesis here would be a positive 121 over 2. Or sorry, over 4. 2 times 2 is 4. All right, so this is the perfect square trinomial right here. But -6 times this gives me the -6p. -6 times the -11p gives me the 66p. So what is the actual value of how much I've changed the value of this expression? Well, I would need to take that 121 over 4 and multiply it by -6 over 1. This has a 2 in common, so then I would get the 121 times 3, and then the sum total value that we would be changing this by, let's not forget this negative here, is a -363 over 2, because this 2 is still here on the bottom as well. Okay, so this would be the total value. All right, so now, again, this is just all expressions. This is just really to cement in how we complete the square. But what we're going to do is we're going to use completing the square to solve quadratic equations. So I've written the steps over here. We're going to go through 4 different equations, and hopefully that beginning part was super helpful for you. So the steps to solving a quadratic equation using completing the square, we're also going to use the square root property. So I'm going to write that up here real quick again. Square root property says that you can take something squared, and if that something squared is equal to b, so if this is true, then a is equal to plus or minus the square root of b. Okay, so that's our square root property. So we'll use that throughout this process. So first things we're going to do, we've got x squared. So now again, we're moving from an expression to an equation that I want to solve. Why do I need to know how to complete the square? Because if I tried factoring, which is the only tool that you have right now, you can't factor this. Because if you looked at the factors of 2, you've only got 2 and 1, and those will never sum to a -2. So this is a prime polynomial. But we can still figure out the value for x that would make this statement true. So again, we've moved into equation land out of expression land. Keep that in mind. So let's see if we can follow these steps here. So we're going to isolate all variable terms. So I want to get these variable terms by themselves. That means I'm just going to move this 2 to the other side. Okay, so it's going to look like this. Okay, so I've got my variables here and then the constant on the other side. Super. Now, if there is a GCF, like we had for those couple of you before, we would factor it out, but this doesn't have a GCF. Yes, they have x's in common, but when we're talking about a GCF, we are talking about only a constant GCF here. Only a constant GCF. So, nothing here to factor out. So now I'm just going to complete the square. I'm going to complete the square by taking this -2, the coefficient of the x term, dividing it by 2 and squaring it. Okay, well that's -1 squared, and -1 squared is just 1. So what I'm going to do then is say what I need to add to this side of the equation to make this a perfect square trinomial is a +1. Well, whatever I do to one side of the equation, I have to do to the other. So I have a 2 over here already, and I need to add 1. All right, so this is now a perfect square trinomial here, and on this side we'll just have 3. So we just completed the square by adding the total value of b over 2 squared to both sides of the equation. The total value here is 1. Okay, now I'm going to factor the resulting perfect square trinomial. Remember, this perfect square trinomial is going to factor like this. The square here is x, and the square here is 1. The sign is going to be this sign right here. So x minus 1 squared is going to be equal to 3. That's what this says, perfect square trinomial in factored form. Now that I've got it in factored form, I can use the square root property. This is a squared term. So I'm just going to take the square root of both sides and get x minus 1 is equal to positive negative square root 3. Can't simplify that down any further. So I'm going to add 1 to both sides and get that x is equal to 1 plus or minus the square root of 3. And that is my solution to this equation. So this is the value that I would plug into x to make this statement true. Now this doesn't really seem like a value, but again, it's 1 plus the square root of 3, which is roughly 2. So this is about 3 and about negative 1. But if we did substitute this value where we see x, this would work out perfectly. Okay, so that's how we're going to use completing the square and the square root property to solve quadratic equations that we previously couldn't solve. All right, so let's do 3 more here, and then we'll call it good. So let's say that we have y squared minus 7y minus 1 is equal to 0. Well, again, my first step here is going to be to isolate all variable terms. Well, these are both variables. This is a constant, so I'm going to get rid of that constant. All right, so we get that y squared minus 7y is equal to 1. Okay, so I'm going to factor out the GCF, constant GCF. There is no constant GCF, so this coefficient here is 1, so we can start and just complete the square. So I'm going to use b, which is this negative 7, put it over 2. Again, we're completing the square here, and square it. Okay, well, this is just going to be negative 7 over 2 times negative 7 over 2, which is a positive 49 over 4. So this would then be y squared minus a 7y. To this side, I'm going to add 49 over 4. And on the other side, I have it equals 1. But then I've also got to add the 49 over 4 to this side. Okay, you can see how these would get pretty ugly. All right, so how do I factor this? That's my next step. I've added the value to both sides, but I need to factor this perfect square trinomial. The thing that's super nice is it's actually already in factored form right here. This is the value. So I'm just going to dump this y into here because that's the a squared part. Okay, a squared goes to a. And this right here, if I were to take the square root of this, it would be 7 halves. Okay, that's pretty easy. This is a negative sign here, so I'm just going to dump the negative sign in. So this is squared. This is going to be equal to, good grief, what is this going to equal? So this is going to be over 1, multiply both the top and the bottom by 4. So I'm really going to have 4 plus 49, which is going to be 53 over 4 on this side. Now that I've factored this perfect square trinomial, I'm going to use the square root property and take the square root of both sides. I have y minus 7 over 2. And this is going to be equal to the plus minus square root 53 over 2. Again, 53 is prime, I think, yeah. And so this is the square root of 53 over the square root of 4. Well, the square root of 4 is just 2. So we're going to leave it like this. Now I'm going to add 7 halves to both sides, and we'll get that our values here are 7 halves. Plus the square root of 53 over 2, and 7 halves minus the square root of 53 over 2. Pretty crazy, but there you go. All right, let's try 2 more of these. And then we'll be done with this section. This is one of the most important sections in this class. Going forward in your math class, this will be very, very important for you to understand and know how to do. Let's do one where we will have a coefficient so we can, or a GCF so we can see what that looks like. All right, so again, my first step is I'm going to isolate all the variable terms. Well, there's variables right here, so that means I'm just going to subtract this 2 over. Okay, so now I'm going to factor out the GCF, but only the constant. Right here, there's a GCF of 3. I'm not going to factor out the p. We need the p's there. Oh, I never thought I'd say that. Okay, p squared minus a 4p. Now we need to say, well, what is going to make this in here a perfect square trinomial? Remember that this is the value for b now, right here. So I'm going to take the value of b, divide it by 2, and square it. Well, that is negative 2 squared, which is 4. So that value is going to go right here, plus 4. But I'm not just going to go, oh, plus 4 right here, because the value that I added right here is not plus 4. Remember that the value of this is 3 times that. So the value that I'm adding to this other side is not 4, it is 12. This is super important. If you have a GCF here, when you complete the square, you need to add the total value, not just the number that completes the square. Okay, so now what do we have? Well, I have this perfect square trinomial. That's equal to 10. I need to factor this perfect square trinomial, which is going to give me p minus 2 squared is going to be equal to 10. All right, well, I want to get this coefficient to be 1. So I'm going to have p minus 2 squared is equal to 10 over 3. Take that square root, because now I've factored the resulting perfect square trinomial, and we're going to use the square root property here. So I get the p minus 2 is equal to square root of 10 over the square root of 3. Well, I need to get rid of this radical in the denominator, so I'm going to multiply both the top and the bottom by the square root of 3. So I'm going to have plus minus square root 30 on top. You can see 10 times 3, and on the bottom just over 3. Then I'm going to add 2 to both sides, and I will get the p is equal to 2 plus or minus the square root of 30 over 3. Pretty big problem to do there. And let's see, we could do one more of these, and then we'll be done with this section. So let's try x squared minus a 10x plus 28 is equal to 0. Again, I want to isolate my x terms, or the variable terms, so I'm going to subtract the 28 from both sides and get that x squared minus 10x is equal to a negative 28. There's no GCF here. Yes, there's x's in common, but again, we're only looking for a constant. There's no constant GCF, so I'm going to complete the square by using the coefficient of the b term, dividing it by 2, and squaring it. That is going to be a negative 5 squared. So sticking that in here on this side of the equation is going to be a plus 25. On the other side of the equation, I have a negative 28, but I'm also going to add 25 because I'm adding the total value of what we did here to both sides of the equation. Now that I have this perfect square trinomial, I'm going to factor it. Remember, this is the x and a 5 and a minus sign right here, so that'll be squared. So this trinomial factors to this, and negative 28 plus 25 is a negative 3. Going to take the square root of both sides now, since I had factored this perfect square trinomial, and I'm going to get the x minus 5 is equal to plus or minus I square root 3. Again, this negative 3 factors to square root of -1 times the square root of 3, and the square root of -1 is I. So we have an imaginary number here. We're gonna add 5 to both sides, and x is going to be equal to 5 plus or minus I square root 3. Right, again, pretty thorough covering of completing the square. I know this was a longer video, but it's a super important concept. So hope that we kind of covered everything and got your questions in the meantime as well.